Hello guys, welcome back. In this video, let us see how to fine tune an LLM in Amazon in AWS directly. So for that, I'm opening SageMaker service. In the SageMaker service, you have IDE option. In these, in these, you have IDE option where you can use these in order to edit or in order to train or in order to perform, write your code, build your code, train your ML model related code. So what is ML model? It's nothing but a backend code itself. So currently we are writing it with Python. Nothing but it's a any ML model. It's nothing but a backend Python code. In order to develop or nothing but a build or train or deploy a ML model, or simply you can say that Python code, you need a platform, right? Yeah, that platform will be provided in this session. That platform will be provided for applications, for building your applications. And the platform or IDEs, integrated development environment, this session is for. You can create your own studio in SageMaker and you can able to use that to create your ML model. It acts like a IDE. The studio acts like a IDE. Now I want to open, or let's say I am more familiar with Jupyter Notebook. Is that facility available in SageMaker in order to write my code, train my code, or you can say in order to write my code to develop my ML model and write my code to fine tune my ML model and deploy my ML model. Do I have any Jupyter Notebook option in the SageMaker? Yes, you have that option as well. You can open notebooks and create your own notebook instance. For this lab, I've already created this lab notebook named notebook instance for us. Now I'm just opening this Jupyter lab. So why I need this Jupyter lab? I need this Jupyter lab in order to build my ML model, and you can able to modify it or you can able to deploy it directly from this notebook. So that's why I already created this notebook for you for this lab. Now, so what is the main aim of this video, sir? The main aim of this video is I want to fine tune an ML model. So whatever the available ML model do I have, that I want to fine tune it. So for that, you can see Hugging a Face. This Hugging Face open source. I'm using this model, this ML model, that is this Databricks Dolly-V2-3B. This data model, this open source data model, I want to use it and I want to train it with my own data. So training any available model with our own data represents what, sir? That is nothing but fine tuning, or you can say improving the learning of this model. So what is the requirement of fine tuning any pre-available model, sir? The requirement is that, so if you fine tune already available model, then it can able to provide the response based on the data that you provided. For training, whatever the data that you provided, based on that data you will get the response. So in that way you can able to get the response based on your required data. If you observe this fine tuning carefully, then you can able to understand the magic behind developing an ML model. in real time, you don't need to develop ML models on your own from scratch. If you observe this fine tuning or you can understood this fine tuning, then you can utilize this knowledge in order to fine tune already available models with your data, and you can able to use that model, ML model, for your requirement. Now you can understood this video carefully, because we are going to do practically how to fine tune a already available model, that is this Databricks Dolly-V2-3B model. We are fine tuning it directly on cloud platform, that is SageMaker. You can see here whatever the required compute that is provided by the instance, based on the instance that we selected, that much of compute we will get, so that we don't need to worry much more about the compute here. Now I'm opening the Jupyter Lab notebook. Here I actually write my own code in order to get. So first, in order to fine tune any ML models, or you can say in order to create any model for your requirement, first, what is the task that you have? You first need to select the appropriate model that best fits for your requirement. So that I've already done. That is, let's say for this demo, I'm picking this, that is a Databricks Dolly-V2-3B model. Now I want to fine tune it. I want to load it with my own request as well as response. That is for particular instruction. Let's say I want particular response. So such a type of data I want to load into this model, into this Databricks Dolly-V2-3B model. So that magic I want to perform. Then I want to deploy that model and I want to use that model. So that's what we're gonna do in this lab. So in order to do that whole thing, first I'm opening a notebook, that is this Conda Python 3 that I'm opening. And in one more new tab, I'm opening a terminal. So this is regarding the terminal and this is regarding our notebook file. In this terminal, from this terminal, I want to import the requirements, or you can say what are the files that I have that I've already stored in my S3. For this demo purpose, I've already created a zip file, where in that zip file I've provided all the required Python codes, that is my model, ML model related code, in order to fine tune my Databricks Dolly-V2. Don't worry, I'll tell you from scratch how to write that code directly from here, that is from this notebook. I'll explain you in this new notebook. So before that, I want to get that notebook, or I want to get that S3 related files for my reference. So I'm just finding those in which bucket my data is there. So current in this bucket, actually my data I have stored. I'm just copying this. And in order to, so first where we are in this SageMaker folder. Let's see what is our present working directory. That's the home under EC2 we are. And in this EC2, let's see what are the folders or files we have. You can see we have, yeah, SageMaker is also one of the folder in it. Now I want to move into this SageMaker. In order to enter to this current location, I just clicking on enter. Now we successfully entered to here. How do you tell we successfully entered to here, sir? You can just list here. You can see we got this untitled library, that is untitled.ipynb, that is a interactive Python notebook file that is visible here. or you can simply write a present working directory. There you can able to identify your current path. Now I want to install my, or I want to copy my file, zip file to here, because there my reference is there. So in order to copy, I'm just writing AWS S3 CP command and S3 colon double slash. In this bucket, my lab codes dot zip file is there. That I'm copying to this current location. So to here, actually that file is copied. Now I'm just clicking on enter. You can see that's got downloaded. You just reload it. You can see got that. Now I want to unzip this. I want to unzip this lab codes dot zip. Now you can again reload. You can see whatever the required files are there, those are all visible here right now. Now let's move on with our ML model related code. So first, what I require, sir, what I need to do at first. So first, in order to fine tune my model that is already available, Hugging Face model, that is a Databricks Dolly-V2 model. So first I need to get this model right. Yes. In order to get this Databricks Dolly-V2 model, we need to install certain specific requirements. So those requirements I have already listed in this requirements.txt file. You can see these all requirements, those I require. Either it may be directly or indirectly. Directly, I require this transformers, because in this transformers only I have auto model for casual LM. So that is there. And tokenizer related functions also present in this transformers itself. I require all those. That is so in order to load my model, I require a function, right? Yeah, that is present in this transformers. So in order to process my data or load my data, in order to load my data, I need a function, right? Yes. So that function is present in this data sets. Similarly, I require other as well. This data set requires this numpy as dependency, and this PEFT, that is a performance efficient fine tuning. I require this in order to fine tune my model with LoRa configurations, that is with a low rank adoption, that is by freezing all the default parameters and providing only the required parameters. That is a low rank adoption model. By using that model, let's say I want to fine tune my model, fine tune my LLM. So for that, I require this PEF. So similar to that, I require PyTorch and IPyCornel. So like that, I require all these dependencies. So that's why I provided all these dependencies. If you did a wrong here, then you might get a lot of errors and mistakes. So must look in these requirements before creating your model and training your model. Because if you install your requirements, if you do not install your requirements correctly, then while importing your transformer, while importing any one of the requirement, let's say transformer, then you might get errors in your code. So that's why I am showing these requirements you this much amount of time. Now I want to install all these required dependencies. You can install all these required dependencies directly from here by just providing a hyphen pip install hyphen r represents requirements. Those are present in which file? In this requirements.txt. So that's why I'm providing that requirements.txt as a file name. Now I don't want output, because if I get output regarding how the files are installing step-by-step result here, then it will be unlooking a good. It will be ungood looking for me. So that's why I want to put in quit mode, QUIET, so that I don't get any installation steps here. And I want to, you can say I'm using pip3 here. I'm using pip3 here because currently this model is Python 3 model, because this requires me Python 3, pip3 related dependencies. So that's why I'm using this. If you use pip, then you might get errors regarding these transformers related dependencies while writing code. So you must need to take care of this. By using what pip, you are installing the requirements as well. And I want to upgrade whatever the SageMaker library I already have. So for that, I am writing the command, that is pip install this SageMaker again. SageMaker, and I don't want output for this as well. So that's why I'm writing quit. And I want to upgrade it. So if I already have this, then I upgrade it, and I want to forcefully reinstall it. So that's why I'm providing this command. And I want to capture these all results. So that's why I'm providing colon, that is this module capture. Now I'm just clicking on this run cell command. You can see here that I'm clicking. Now if you observe, our kernel is now busy because it is executing this command. So that's why currently it is busy state. So wait till the requirements got installed. You can see our kernel is now idle state. That means all the required dependencies will be successfully installed in your system. So why this step was to install the requirements, to install the required dependencies. So we installed our required dependencies successfully. Now what I want, so first we install the required dependencies. Now I want to load my model to here. What I want to provide my model here. I want to load my model here. So in order to get your model, I want to get my model here. So in order to get your model, what is your model? That is this Hugging Face related model, right? That is Databricks Dolly-V2. So that you can able to get by using this command. You can see that here, yeah, this is the model that you are taking from where, by using this auto model for casual LM. By using this one, you're getting your model, that is a Databricks Dolly-V2-3B model, by mapping your device to auto. Now let's write this command, and let's look at one more thing, that is so where this auto model for casual LM is present. This actually present in transformers. So we need to import this from transformers. We have already installed the transformers from these requirements. You can see by using this command. Now I'm importing that from transformers. I'm importing what? Auto model for casual LM. CAUSAL. Casual spelling is CAUSAL. You can even look at here, CAUSAL. Yeah. So if you provide a wrong spelling, then you might get error. So don't be panic. If you get error, then please try to take a bit time and try to observe it. Now I want to load my model into this model variable. So that's why I'm providing model as a variable. So in order to load my model, I'm writing this auto model for casual LM, and by using what we can able to load is, so this having from pre-trained, from pre-trained, from pre-trained. You can able to observe this reference as well, from pre-trained. Yeah. So what is the model? That model name you need to provide at first. You can see now I just providing that model name. That model is nothing but Databricks. So under this Databricks, I have that Dolly V2-3B model. So here you can provide the model that you chosen in order to fine tune that, and then you need to provide the device type. So what is your device type? I'm providing here auto as the device type. Then, so which type of data you want to load, that you want to provide. I want to load in 8-bit data. So that's why I'm providing load 8-bit is equals to true. So here I defined my model like this. I hope you understood this. Okay, now in order to load my model, I have written the code. So I'm just running this cell so that this will load. We get one more error, that is a transformers, no module name. Transformers. Might we return some name mistake, TRANSFORMERS. So let's open it. TRANSFORMERS. The same name, right? So let's copy it again and let's try to paste it here, and let's try to rerun it. So again we got no module with the name this. I think the requirements are not installed. So let's rerun this first line. Yeah, there is a error at this capture. So let's re-verify it. I don't think there will be a mistake here. Let's provide some space here and just so again we're getting some error here. So I think we need to provide this capture in the first line. Yeah, that's what the error mistake. Now I'm just rerunning it. Yeah, you can see this is running right now. Yeah, that was run successfully. Now I'm just rerunning this. So again we're getting the same error, that is transformers not found. Might there will be an error with dependencies in string. So I'm just removing this comment and just rerunning the same code here. So now again the kernel will be busy. That is this cell is working, running. So after the cell will work, so what are the requirements which are present in this file will got installed. So then after we'll load our model. Or else if you just click on run, then simultaneously the second step, after this step, this cell will be run. You can wait, or you just click on this, that is this run the selected cell, so that this selected cell will automatically run after the previous cell that you run. Currently one cell is running. Let's wait. I think it's taking a bit more time. That means it is installing the requirements right now. You can even identify that what are the requirements which are installed by using a pip list command. You can write that pip space list command here so that you can able to list what are the requirements that are installed. Yeah, I think it's 90 seconds. Let's wait for few more seconds, 2 minutes, so that what are the required dependencies that we provided, those all will get installed. Now you can see our kernel status is ideal. That means all the requirements will get installed. Now I want to run this. I want to run this so that I'll load my casual language model. So I'm just clicking on run. So again, now we get error here. That means, so this first line got run. That means that this transformers got successfully installed. So now we are getting in this line. That means we might provided the name error, that is auto model for casual. So I think the casual spelling is wrong here. CAUSAL, casual LM for pre-trained model. Now I'm just rerunning this cell. Yeah, so currently the cell is running. So this model is now, I think we might read one more mistake. So let's revalidate it. I think maybe the mistake will be with this device type. Actually, here the device map is there, not the device type. You can open the reference here. You can able to identify that. So where is that? So where the model? Where? Yeah, here the model is there. Yeah, you can see. I think the device map, instead of device map, we provided that device type. So that's for the error. I'm just rerunning this cell again. Yeah, now this model is loading right now. So we downloaded all the required dependencies from this file, and we even loaded our model as well. So in between you might get some errors. You can rectify them by correctly providing the correct commands, right? Yeah. Then okay, now we get our model as well. So before training my model, I want to see the CPU memory utilization. I want to see the memory utilization. How to see that memory utilization? For that, you have this nvidia-smi command. You just write this and just click on enter, or you run that cell. Since it's a window, I'm just clicking on shift and enter, so that this cell will run automatically. Now you can observe, so currently it's actually running. Since we downloaded this model here, so that's why it's occupied this much amount of memory. That is a 3407 MBPS out of 15, approximately 15,500, like that. It's a 15,360 Mbps out of 15,000 Mbps. Already the 3,000 Mbps was occupied of your memory usage. So more than half memory is empty, not utilized. So I can use this model, or I can continue to fine tune this model directly from this notebook itself. Now okay, my memory is available, so that I can able to fine tune my model. So in order to fine tune my model with my personal data, first we need to provide some personal data, or we need to load my personal data in this notebook, right? Yeah. So how to load your personal data? Actually, I stored my personal data in this format. You can see in this Excel format, I loaded my personal data. You can observe the name of this file as well. That is Amazon SageMaker frequently asked questions. In real time, you might need to provide your data, that is your personal, or regarding the client requirements, or regarding your application requirements data, or your natural requirements. Based on that type of data you need to load, right? Yeah. So now for this demo, I'm using this already available Amazon SageMaker frequently asked questions .csv file. You can see that data will look like this. It's having instruction as well as response. Totally 154 rows of data I have. I want to load this whole data, and I want to train, or I want to fine tune this LLM, that is this Databricks Dolly-V2-3B LLM. I want to fine tune it by using this data. So after fine tuning it, if I provide this instruction, then I might need to get this as my response. We can even validate that at the end as well. So first I want to load this data at first here. So in order to load my data, so in order to load your data, I require this load data sets. I require this load data sets function. In this load data sets, you need to specify what type of format your data will be. This is a CSV type format. So that's why I'm providing CSV, and you need to provide your data files related path. So where these data files are present, currently this untitled.i Python library or interactive Python notebook present in this SageMaker folder. So where my data is present? In this data folder, that is from this current location. If I am looking, then in this data folder, in this Amazon SageMaker frequently asked FAQ.csv. So that's the file location. I'm just providing the same here. Amazon SageMaker underscore FAQs dot CSV. Now I provided the location as well. Now, so where this data sets function is available, from where I need to import this. So from where I need to import this load data sets. You can import this load data sets from a module. That is, from which module I can able to import this load data set, sir? From data set module, you can able to import that. So let's see, in requirements, do I install that? Yeah, that's a data sets. From data sets, you can able to import this load data set. Now from there, I imported this load data set, and by using that, I'm loading my model and storing that data in D1 variable. In D1 variable, I actually storing that data. Now I want to print that data. So that's why I'm using this print command, print of D1. Now you can press shift and enter, or else you just simply run this cell. So currently it is running. So after your whole data got loaded into this D1 variable, currently it will print. Now you can see it got printed, right? Yeah. So totally how many number of rows? 154. So what are the features that each row has? Instruction as well as a response. So currently what data set you are holding? I am holding a data set where it contains a train as a key and that train actually contains my data. So what I want this data need to be stored in this D1. So that's why from the getting response, I'm just again getting only this data set, getting only this data set by providing a train here. Now I'm just rerunning this cell. You can see now whenever we type D1, we get the data set. If you want the first row of your data set, then just provide D1 of 0 so that you can get the first row of your data set. So this is the first instruction and that instruction related response. Okay, I'm getting my data. Now I have my data set loaded and I have my model already loaded here. So can I able to fine tune it? Yeah. So before that, so is this type of response looking good to you? No, right? Yeah. So if you open any real-time chatbots, how the format of the response will be? The format of the response will look like, so there will be some intro and there will be some instruction and there will be some response, right? Yeah. So like this, in this format, you will have that, right? Yeah. So now let's say I want my data to be appear in that format. Can I able to arrange that? Yeah, you can able to arrange that by using formatting strings concept. You can able to create your own format as well. So for that, I am using this prompt prompt variable, and in this prompt variable, I am storing this format and dot by using dot format by using this dot format function. I am specifying this variable holding value as well. This intro need to hold some introduction, that is like this is your task. So this is your task. So like that, I'm providing intro. Then what about instruction? Instruction need to be like I want my instruction as, so whatever the instruction that I am getting, right? Yeah. So whatever the instruction that I am getting from user that I want to provide. So that's I need to provide it dynamically. So that's why I'm providing instruction within this braces. Then so in response place, what I need to provide. So what are the response that is coming from my model that I need to place here. So that's why again, since it's a dynamic one, or you can say whatever the response that I'm getting from my model. So that's why I'm providing again it in a this braces. Now on above of instruction, in order to identify that it's as an instruction. So that's why I'm providing like this as instruction, and at the before response also, let's say I want to provide the same format. I want to tell it as a response and I want to get the response. And at last I want to tell it's an end. So that's why I provided an end token here, and I'm providing the variable value for end as well, that is this end, by just providing end here. Now you can able to print this prompt as well, so that you can able to see the how the format will be. Now I'm just running this cell. Yeah, you can observe so how the format will be. Yeah, wow, it's look like a simple chatbot response, right? Yeah. So there will be instruction for under that whatever the instruction that is provided by client, that is visible here, and under the response whatever the response that I will get from my model, that will be visible here, and this represents the end, right? Yeah. So you can even provide these similar to here itself. So let's make it as well. I N Similar to this, I'm providing instruction one. So like that, I provided the name, and I providing that in this format itself, the values directly. So this is the value for what? This is the value need to get at place of instruction one. I'm just copying it and pasting that here. Yeah, that's it. So in this place, I need to get the rest. Let's say I want the format to be same. Response one I'm providing to make it look good to me. I provided like that. So where it was under instruction. So that's why here I'm writing that. What is that? Response one. The value need to be within strings. That is this. Yeah. Okay. So now let's reload this, or you can say let's rerun this cell. We can say we get the same. Okay. We defined the prompt. So how the prompt that I require, like that I defined a prompt variable. Now I want to convert. So whatever the data that I have, whatever the data I have that I want to convert into this format, right? I want to convert into this format. In order to convert into this format, now I want to define a function. FORMAT format converter. So CONV. So like that I provided the name, and whenever it gets some record, so what I'm doing, I'm just adding some field to this record. That is text field I'm adding to this record, and for that I'm providing the response as through this prompt prompt dot format of. So what I need to provide in each record, what I have instruction as well as response I have. Here I need to pass those two as parameters to this prompt. So those two I need to pass, right? Yeah. So in order to pass those two, for this instruction, I'm just copying. I want to pass the record instruction. So whatever the instruction that is present in the record, that I am passing here. And for response, for this response place, what I want, so whatever the response that is present in my record, that I want to pass. So I'm providing the record response. The response name is small response. Okay. I'm just, yeah. We defined again, yeah, we defined a function where it will take the record, and for that record it will add one more field, that is text. That text will contain this format of response, this prompt format of response. So for that we provided the required things. Yeah. Okay. Now I actually want to convert this data set. I want to convert this D1 data set into this format. So for that, you can just use a d1.map function. So whatever the function, to what function you want to map your variable, that function name you need to write. So that function name is this. I'm just copying this and pasting that here. At last, so what happened? So whatever the record. So first, this map function will take each and every record from this D1. Then it will pass to this function. So what happens? It will came to here and it will create some text format record. At last, I need to return that record as well, because previously in my record, I only have this instruction as well as response. whenever this function is called, to that record, this also get added. Now I'm returning that record, and again I'm storing in this D1. So that's why I'm providing a D1 itself. Now you can able to print D1 of 0, and you can able to check whether this another field is added in your, whether this another field is added in your records or not, and that field will contain this type of or your required format of prompt response or not. So that's why I'm just printing this. Let's run this cell. Okay, we encountered one more error. Okay, that is this. So let's validate it, or let's observe this. Now let's see the error. So key error, that is instruction might, it gets confusing with the name. So let's provide with a small case letters, small instruction and small case response. Here also I'm modifying small case instruction and small case response. And now let's provide here itself, here also, that is a small case instruction, small case response. Now let's rerun the above cell as well as the below cell as well. Okay, the above cell run. Now the below cell is running. Yeah, you can see, you can observe D1 of 0. That response is right now this. Before this response D1 of 0, we'll have only this instruction as well as response. Now one more field, that is this text field, got added. Due to this function mapping, this text field got added into every record, not only D1 of 0, for every record, that is 154 records are there, I might think. Those all 154 records. So if you can open this, yeah. So for these all 154 records, in this function, actually this text field also get added. So let's see only that text field data here by just providing text. Now let's rerun it. You can see this is the text field format of data. So this is how we get the response in real time. Okay, now we converted, so whatever the data that we have, into our required format, into our required good looking format, right? Yes. Now we converted into required format. Now what we want to use this D1 data to fine tune the model that I have loaded, right? So to this model, I want to use this data to fine tune that model. So now first we have the question, that is, can I fine tune that model directly with this data? No, you cannot able to fine tune your data directly by using this data. So in order to fine tune your model, which type of data you require, sir? You need tokens. You need tokens of data in order to fine tune your model. Okay, then we need to convert this data into tokens, right? Yes. So how can I convert this data into tokens, sir? So let's refer again this Hugging Face model. If you observe, there is a tokenizer. Where is that? Yeah, you can see by using this auto tokenizer, you can able to load your model related tokenizer. For every model tokenizer is there, you can able to load that tokenizer for that model. So for which model you are creating your tokenizer, for that you need to specify the model name, and you can able to load the tokenizer, and you need to specify which side you want to add the padding, that is, in which side you want to add your sequence. So where this auto tokenizer is present, again, this auto tokenizer also present in this transformers. If you recall, so in order to load your model, you require this auto model for casual LM that also present in your transformers module. Now, in order to load tokenizers or in order to create tokenizers for your model, you again importing this auto tokenizer from which module? From this transformer module. Now let's import this tokenizer from transformers module. Auto tokenizer is the name that it has. Z is the tokenizer spelling. Then, so you need to provide some tokenizer variable name. So let me provide the name the same, that is a tokenizer. And there you can able to load the tokenizer. So auto tokenizer dot, by using this method, dot from pre-trained, from pre-trained from pre-trained model, you are loading this tokenizer. What is your model? That is Databricks forward slash. So what is that? Dolly hyphen version 2, where that model is loaded with actually trained, previously trained with 3 billion data. So that's why 3B. And you need to tell what is the padding side. So currently I want to pad in left side. So that's why I'm providing left. Yeah, that's it. You just rerun it so that you can see your tokenizer will be just now created. Then currently I want to specify the padding tokens as well. For this tokenizer, I want to specify pad tokens. Pad token I want to specify. So what is a pad token that you want to specify? Let's say I want to specify my pad token for this tokenizer as end of sequence. So tokenizer dot EOS, end of sequence token, I'm specifying as padding token. Then I want to add some special token, additional tokens. Let's say I want to add to it. So for that, before that, the pad tokens, it's a tokenizer dot pad tokens. For padding tokens, I'm using this end of sequence as the padding token. Then what I want additional tokens. I want to add additional tokens. So that's why I'm writing the command, that is tokenizer dot add special tokens. So what are my special tokens? Nothing but your intro. That is nothing but. So what are the special tokens that you have? So this is one special token, and I want to provide these instruction response as well as end as the tokens. So that's why I'm writing this tokenizer dot. For this tokenizer, I'm providing those as special tokens. Within this, I'm providing it in a flower braces, and you need to provide the name of it. Additional special tokens. Additional special tokens, I want to add them. And here I'm providing those. Those are end is one token, instruction it is one token, and response is one token. I want to define these three variables at top before using them. So for end, I want the end token. What is the end token that we are using? You can see this double slash end is the end token that we are using. That's what I'm providing here right now. So I'm just copying this that is a double slash and I'm just copying, and yeah, that's I'm pasting in place of end. And for instruction, how the token will be like this. So these are additional special tokens that I've provided. Then I have the response token as well, that is this. These are not required, these are just additional tokens, so that's why I'm specifying this. And I'm just rerunning this cell. You can say I provided 3 tokens, those are visible here, 3. Now we actually created our tokenizer with special tokens. Whatever the special tokens that we want to add, by using that we created a tokenizer. Now we need to update this tokenizer length as well. That is, we need to embed this tokenizer length as well in our fine tuning, or else you can say in our LLM model. So that's why I'm writing here model dot resize command. Model dot resize token embeddings, right? We need to resize. So that's why token embeddings of, based on what we need to resize our model token embeddings, based on the length of tokenizer, based on the length of this tokenizer. So I provided this and just clicking on enter. Now the embeddings also changed, or you can say resized, for our model based on that tokenizer that we provided. In this tokenizer we added special tokens, that is the required special tokens, and we resized the token embeddings of our model as well based on our tokenizer, right? Yes. Now what is the thing left with? We need to convert whatever the data, that is the D1 data we have, whatever the D1 data that we have, we need to convert that raw data in order to raw text to tokens. By using what? By using this tokenizer that we just now created. Before you tokenize your raw data, that is D1, with this tokenizer, first you need to tell a parameter, that is max length. So what is the max length? By using that, you want to tokenize your data. So for this demo, I'm using a 256 as a max length. By using that, I want to tokenize my raw data, that is D1, by using that tokenizer that I created. For that Databricks Dolly-V2-3B model. So for that, in order to tokenize, I'm creating one more function, that is by using def keyword, I'm creating one more function. Since this is a pre-processing, since it's a pre-processing of my batch data, or you can say D1 data, I'm just providing the name like so something you can provide MLU underscore pre-process batch, or you can just provide a simplest name like mm, raw to tokens. So very simple, like that you can able to provide. For this, what you are providing the inputs, you need to provide the token, and that is the tokenizer you need to provide, as well as max length you need to provide, as well as, so which data you want to tokenize, that data, let's assume that as a batch data, a batch of data. So that's why I'm providing the name like that. Then I need to tokenize that data, and then I need to return that data. So I think max raw to tokens, right? Yeah. Then I need to return that data, right? Yeah. So in order to return, I'm writing this return command. In order to tokenize, with this tokenizer, I'm writing this tokenizer of. So what batch data we're getting? This is the batch, right? Yeah. In this batch, what data I need to pre-process or I need to tokenize? I just need this text data. I just need the text data in each and every record. Or not a batch data, you can just simply type it as record data. So for each and every record, I'm just picking the text and I need to tokenize it based on the max length that I'm using. So for this, I'm using this max length, whatever the length that I'm passing, that I even defined previously, and truncation. So do you want to truncate it after this max length? Yes. So that's why I'm providing truncation is equals to true. Yeah, that's it. Let's provide some spaces here so that. So what's the mistake? Expect two blank lines. Okay. So let's move on. If we might encounter any errors, then there we'll get and remodify that code again. Now this function will take the records in the form of text and then it will tokenize that data and just that tokens it will return back, right? Yeah, based on the max length that we provided, it will create the tokens and it will return that tokens back. In order to map this function, to my data, I need to create, I need to use a partial method where this method is present in function tools. So that's why I'm importing this partial. So in this partial, I'm providing this function name and here I'm adding this function with tokenizer as well as max length. Yeah, that's it. Now I'm just providing the name of this function like so since it's a partial function, or you can say since we are using it to map to pre-processing, that is a raw to tokenizing, so let's provide the name as pre-processor, pre-process. So like that, let's provide the name, just to provide some space so that yeah, you might not get errors. Then so what I need to do, we created this pre-processing function as well in order to convert the raw data of my records into what? Into my tokens. And we mapped our function with tokenizer as well as max length as well. Then what is the left thing? We need to convert our data, D1 data, into this tokens. So in order to do that, you just map, that's it. So you have already seen the mapping previously, that is this. So let's write that in more efficient way, d1 dot map. And to what function you are mapping? To this pre-process function you are mapping. So I'm mapping to that. Then, so let me store it in encoded way, or else you can say I want to store it in one more variable. That mapping I want to store in one more variable. Encoded d1. So like that I want to store, so that's why I provided the name like that. And that pre-processing happened. Okay, so then let's provide some more details here. It's a batch type matching, it's a batch type processing mapping, or it's a batch type mapping. So that's why I provided batched. So that's why I'm providing true. Then here you need to provide whatever the removed columns. You can see you have added some additional tokens, right? So those tokens you need to provide here before tokenizing. Since you're mapping raw data into tokens, right? So there you don't need to tokenize these additional names. So in order to remove those columns, I'm providing this command, that is remove columns is equals to this. I'm just clicking on enter. So let's click. Yeah, seems to be everything is fine. Okay, the encoded data, that is a d1 is mapped to this preprocess function. Then that will call this a raw to token. Then here actually your data is that is your tokenizer will convert your record of text into based on your max length that you provided here. Then that encoded data will be stored here. So in batched way your data will be sent to this preprocess, and these removed columns will be these columns will be removed that you provided here. Now let's implement this raw to tokenization function by just running this cell. Now you can say I'm running this cell. So we might got some error, that is a record of this text. Since we are passing here the batch data, we need to provide here batch. I think that's the mistake that we encountered. Now I'm just rerunning this cell. So again there will be some error. So GPT Neo X tokenizer object is not subscriptable. So what happened? Might passing these parameters to here, it will be confused. So let's provide the tokenizer name here. The tokenizer, for the tokenizer variable, I'm providing this tokenizer as the name, and for max length parameter, I'm passing this value. So that's why I'm providing this. And let's retry it. Okay, now actually the mapping is done. So our raw data gets encoded right now successfully. So it's even in idle state. Let's provide a record as well. So let's provide the name as the record here itself. And let's retry to rerun it. It's again running. Okay. The issue is that is here, since we even not provided the names or related to parameters. That's why it is confusing a bit. So that's it. That's the only issue happened here. Okay. Now our data gets encoded. You can even see that by just printing that data. Encoded D1. And you just run this cell. You can see 154 rows with this data, with this input IDs, and each row is having input IDs as well as attention mask as well. You can see the first value. Since it's encoded, I think we can't able to read. Yeah, you can see since it's encoded, we cannot able to understood this. Since it's converted into tokens by using this tokenizer, we cannot able to understood this, right? Yeah. Okay. So let me delete this box. Yeah, I deleted that cell. So we successfully converted our data into what? Into tokens, into encoded form of tokens by using the tokenizer that we created for the available model. Now we have multiple records in this encoded. In this encoded D1 as well, we have multiple records. That is, we have seen totally how many records? I think encoded. Yeah. So we have 154 records. I don't want those many records. I just want the records which are having less than this max length. So in order to train my model and test my model, I just required only the records which are less than 256 max length. So in order to filter those records in this encoded data, you can use that filter function for this encoded D1 data dot filter of. You can provide here the function name, or if you are familiar with the lambda function, then you can use that lambda function as well. Since I'm good enough with lambda functions writing, I'm just writing some lambda code, that is a lambda record. So whatever the record that we are getting, that we are passing back. When we are checking the length, we are checking the length of our encoded data. We are checking the length of our encoded length of our record, length of our record related this input id value. This input id's value is greater than the max length that we specified, or that is a less than, right? Yeah, less than max length that we specified. So whenever this condition is true, that is whenever the length of input IDs of my record that is less than the max length that is specified, that record only filtered. And now I want to store that processed data. I want to store that data in one more variable in order to fine tune my model. So I'm just using some variable name like processed data set, like that. I'm using some variable name. Yeah, now I'm just running this. So might, okay, length is not there. The function name is len. Now I'm just rerunning this. Okay. So this len function in Python is used to identify the length of this string or whatever it may be. That is a whatever the collection it may be. Either it may be a list or tuple or sequence or string. This len function will identify the length. Okay. Okay. Now in encoded D1 data, that is a tokenized raw data, also we are filtering the records based on the max length that we provided, and we stored that data here in this processed data. Previously we have 154 records. Let's print and check how many records that we have processed, how many records that we have in this processed data. So 148 records are there. The other records in this 154, only 148 records are satisfying this condition, that is length of that record of input IDs is less than max length. Other records are not satisfying, so those all filtered and we only get this data. So now we can able to use this data to train our model and to test our model as well. Now to train my data set and to test my data set, I want to split this processed data. So for that, I'm using processed data dot split. You can see train test split. So that is visible here, that you can able to use in order to train, and for splitting your data into two parts, for training as well as for testing. I'm using that. You can see train test split of. So what is your, so how many samples you want for testing. That test size you need to provide. I'm providing that test size as 14, and seed I'm providing as 0. Now I'm storing this in one more variable, that is split, that is split data set. In this split data set variable, I want to store this split underscore data set variable. I want to store this. So I'm just rerunning this cell again. Okay, this will, I think, yeah, this will done. Let's print and check whether this split data set variable is holding that data or not. I'm just rerunning it. You can see it is holding two types of data sets. One is for testing, one is for training. So for testing, how many number of rows, that is how many number of records it is holding? 14. That's what we specified, right? Yes. Then for training, all the other records other than 14, how many records are there? Those all I'm using for training. So like that, the data set will be splitted. So whenever I provide this split data set of train, then I'll get these 134 records. Whenever I type split data set of this test, then I'll get this 14 records. So those I gonna use in order to train and test my data set. That is my model. For my model training and testing, I'll use this data set. This split data set I'll use for training and testing. So if we look back, then we can able to see we first loaded our model. Then we checked the memory usage status. Then we loaded our data set. Then we just converted our data set into required format. For that, we defined the prompt format. Then for converting, we defined the function, and then we converted our data into the required data format. So in order to use our data set, first we need to, or in order to use our data set for pre-training, we need to convert our data set into tokens. So for that, we need tokenizer. So that's we imported from transformers, and we created a tokenizer for the model that we are going to train. And we even specified the padding side. Then the required details like padding tokens and additional special tokens what we are going to add, those all we specified for tokenizer. Based on the tokens we added, we even resized our token embeddings of our model. Then we need to fine tune our model, right? For that, the raw data is not used. For that, the tokens data is used. So we are using this tokenizer. Here we defined some functions in order to convert our raw data into tokenized data, and that data, tokenized data, we stored in this encoded D1 variable. Then we again filter the data based on this max length. Then we split the data into two parts. One is for training and one is for testing. For testing, we are holding only 14 records. For training, we are holding 134 records. Okay. Now let's step forward. Now for pre-training, so what are the model that we get? So in order to fine tune that model, we have multiple options. We can fine tune it with providing all parameters, or we can freeze specific weights, and we can able to provide only less configurations, and we can able to train our model. So now in this demo, I want to move on with this efficient process, that is best practice process. We can just freeze other weights, and we can only configure less, that is low LoRa configurations. By configuring in LoRa model, we are now fine tuning our model. So in order to fine tune our model with LoRa configurations, you can use PEF. We can use get PEF model. We can use get PEF model for our model. And we can specify LoRa configurations as parameter here. We can provide LoRa configurations as parameter here, and we can assign it to our model. So we need to define this LoRa config, right? That is this LoRa configurations we need to define. Before that, we need to import this get PEFT model function also, right? In order to import this, so from where we need to import this? This actually present in PEFT. PEFT. So what is this PEFT, sir? Parameter efficient fine tuning. What is this PEFT? Parameter efficient fine tuning. In this parameter efficient fine tuning only, you have LoRa config class also present. By using that LoRa config class, you can able to specify LoRa configurations, and by using this get PEFT model, you can able to assign the configurations to your model. Now let's define this LoRa config. Let's define this LoRa config parameters. So what is meant by LoRa, sir? So LoRa is nothing but, so let's write the extensions as well. LoRa, LoRa. So LoRa means low rank adoption. LoRa stands for low rank adoption. Whereas this PEFT stands for parameter efficient fine tuning. Parameter efficient fine tuning. Okay. So now we need to provide this LoRa configurations, right? So in order to provide LoRa configurations, we are using this LoRa config. So since you are using this LoRa config, it will freeze all the other weights, and we can even we just need to provide the LoRa configurations. Here we need to provide a rank. R represents rank. So what is the rank? Here I want to provide the rank as 256. I want to provide the rank as 256. Then we also need to provide LoRa related alpha. So what is this LoRa alpha, sir? This LoRa alpha is nothing but scaling factor for your low rank matrix. Currently I want to scale it up to 512. So that's why I provided this. Then we also have LoRa dropout. This LoRa dropout specifies the dropout probability of your LoRa variables. So for that I'm providing 0.05, and I even provided the description for that as well. Here we again need to provide two more parameters, that is a bias as well as the task type. Bias is actually none, and nothing is biased here. And task type I'm using casual LM. So that's it. We provided LoRa configurations, and we even used this getPEFT model in order to apply those LoRa config parameters to your model. Then after after doing this configuration, I want to print the trainable parameters. So that's why I'm writing this command. So then I'm just running this cell. Currently the kernel is busy. Yeah, it's done. You can see the training parameters are these, and all parameters are these, and trainable parameters are these. Trainable parameters percentage. Yeah. So our model is even loaded with LoRa configurations. Now our training data is available. That is, our training as well as testing data is available, and our model is also available. So now what we need to do? We need to collect this data, then we need to train this model. So in order to do that, so what we need to define, sir? First, we need to extend the collector class from your model. This is where actually the magic happens. Now I'm defining the collector. So you just keenly observe this step. Now I want to override this class data collector for language modeling. So whenever I override this, then what happens? What happens is for your model, what are the model that you're using? That related data you are actually overriding by creating a class here. You are actually overriding that model with your data. That is nothing but your trained data set. You are modeling the data. So for that, you are creating a class right now. So keenly observe it. Now you can observe this data collector. I am extending it with one more class. So this is what the class that I am creating. In this, I gonna define a function. You can see this is torch all, torch call. So like that, I'm creating one more function where it will take examples. That examples is in this format, in this list format of examples that it will take, where this will contain a union of list as well as any as well as dictionary type data. Then I gonna pre-process that here. So first it will take that type of data. The starch call will override the same method. The starch call will override the same method at where? In this base class. In this base class, it actually overrides this torch call. The same method it will override. After encoding, what I am doing? After encoding, I'm just so let us provide the correct indent here. After encoding, so what we are doing? We are doing this. That is, we are encoding our response. This response we defined as an end. You can see here for that tokenizer, this response we defined as end. As a special token, we defined it as an end. So that response we are encoding. What we're doing, we are encoding that response. Then it finds that token. So what it will do, it will identify the token ID. It will identify the token ID and it will check. So what is the ID? At which index in labels this token is present? It will find that index. So based on the response token, it will identify the ID. Based on the response token, what it will do? It will search through this labels data, and it will identify the index of the response token. So like this, it identifies the response token index. Here, two cases may happen. One is it will find the index, and the other case is it may not find the index. So if it finds the index, then it will also identify the end index of that response token. The other way, that is the other possibility, if it does not find the index, it just throws you a runtime error. So like that, I want to write the code here in if else statement. Now you can say provided if response token ID starts index is none, that is not found, I'm just raising a runtime error. If it founds, then I'm just considering the end index as start index plus 1. So like that, I am identifying the end index. Now, to train the model to predict only the response, and ignore the prompt tokens. The prompt tokens we provided, right? So we need to ignore them and we need to provide only the response. So for that, we set this value, labels of this value, this I till this response end index, we are providing it as minus 100, and we are ensuring that these tokens are ignored, and we are providing the batch labels data again as the final processed labels, and we are returning the batch at the end whenever this method got or this class got called. So whenever this class got called, this method will overrides already available method. That's the first thing happened. Then it will take the responses to be in encoded format by using that tokenizer. Then after it will identify the labels, then my response related IDs are present or not. So that particular IDs it will identify. If found, then it will identify the end as well, and it will ignore the tokens. So whatever the response tokens are there, those will be ignored, and that batch response will be returning. If that is not identified, the response token is not identified, then we're simply raising a runtime error. So like that, we created a data collector class. With this model data collector, now since we created this class for overriding the data collector for language modeling, now we can able to define our data collector. So now I'm defining this data collector variable. For this, I am using this class, whatever the class that we defined, that I am using, and I am passing the parameters, that is tokenizer. I'm passing the parameters, that is tokenizer as one value, and MLM I'll pass, that is MLM is equals to false, and return, and we need to even provide two more parameters, this return tensors as well as this pad to multiple of 8. So now we created a data collector. So we just need to run this so that this whole magic will happen. That is, it will collect the labels based on our responses, and that overriding will happen. Then Yeah, that data collector will be defined here. Now I'm just running this. If we have any errors, then that might show here. Yeah, list is not defined. So in order to get the list, we can use a typing function. From typing module, we can able to import that list, int, any, dict, union. So these all we can able to import. So in order to import that from typing, I'm just return this command. And so let's create a collator. And we then use that collator while training our model. TOLLATOR. So like that we use the name, so that we're gonna use in training. And do we forgot any other things that we missed? I think here NP is missed. We're using it instead of NumPy. I am importing NumPy as NP. And now I'm just running this cell again. Now let's see. Yeah, I think yeah. So nothing errors I'm getting. You can even rerun this. Yeah, still no errors are there. And my kernel is still in ideal state. That means so everything is working fine. Now we defined our data collator and we defined our data sets for training. So we just need to define our trainer in order to train our data. So in order to train our data, let's define the trainer. That trainer also present in transformers. So let's import that from transformers. From transformers, I'm importing trainer. Then I'm using that trainer. So in order to define my trainer. So in order to define my trainer, I'm using that trainer. I'm defining the trainer to this trainer variable. So for this trainer, I'm providing the values like what model I want to train. That model name I provided and what tokenizer that I use to train this model. So that tokenizer I'm specifying, and we need to tell the test data as well as train data as right. Yes, to tell test and train data, you can see I have these two variables, that is a test and evaluate data set. So by using these two, we provided split data set of this train for training, and for evaluation purpose we provide this test. So then we need to tell the data collator that we previously defined. So in order to collect the data, we defined this data collator, right? Yeah. So let's use that here. For data collator, we are using that data collator. In addition to this, we also need to provide another parameter for this. That is augments, ARGS. This arguments we need to define right now. That is training arguments. Let us define right now. For defining this training arguments also, we need to import one more. We need to import one more from this transformers. That is training arguments. That is this training arguments I'm using to define these training parameters. So let's define these training parameters here. You can see I have provided the training parameters, that is output directory. In this model save folder name I'm storing, those I am defining here. You can see this model save folder name that I'm providing, this Dolly-V2-3B LoRa is the folder name that I provided, and at what learning rate this trainer will learn. that is 10 power minus 4. You can see, so where here I provided that learning rate, and how many number of train epochs, you can say I'm providing a 10, and I'm providing the other details like per device train batch size and evaluation size, and logging strategy and steps, evaluation strategy and their steps, saving strategy and their steps, and total limit. So these all I've provided. Now I've defined my trainer here by this training arguments. At last, let us provide the training configuration regarding cache. You can say I'm just providing false for caching, and now I'm just providing trainer.train. Now I'm just moving back. Currently, I do not have, I even reload, I do not have the folder with this name. After training this folder will be created. So let's, the model that we provided that got trained with this tokenizer, with this training data set, and then with this data collator, your data will be collected and collated. Then yeah, you can, this evaluation data set is used for evaluating. For trainer, we provided even the augments, right? Yeah. Now I'm just running this so that this will start run. I think this name is not defined. Hmm. So what's the error? Response is not defined. In this response, so let's move back to validate it. So where is that? That is here. So here it is undefined. So let's move back and see what is the response name that we previously provided. Now, if you observe, the response name that we provided is capital R. So let's try with that. Now I'm again rerunning this cell as well as this cell as well. Yeah, currently, yeah. Now actually our training got started. So what are the model that you provided? So that training got started here. Here, yeah, this is the response that you're using. So that's why that name you need to use there. Yeah, now it's training. This training of data set may take a bit moment of time. You just need to wait. I'm just passing it. You can see this training was happened. You can see the training loss and validation loss, and the steps also visible here. So the whole training was done. So our model training was happened. So we successfully trained our model with our data set. Now you can able to observe here that is a Dolly-3B mode, that is a Dolly-3B LoRa folder also created here, right? Yes. So from this we can able to say that this training got completed successfully. We trained our model, already available model, with our data. So after training this data, so what is the next step? We're gonna use it, right? Yeah. So in order to use it, we need to deploy it. So in order to deploy it, we first need to save this model inside one of your S3 bucket. Then only you can able to use that model and you can able to deploy that model. So in order to save my model in S3, let's save that model here. Let's save that model related artifact files here. So for that, let's write the commands. Now I'm saving this pre-trained model by using this command. that is a trainer dot model dot save pre-trained in this folder. And I'm just running this cell. You can see again this folder just created. In this, the model related pre-trained trainer data related JSON as well as this adapter model related bin got stored here. Now I want to save my model as well. In order to save my model, let's write this trainer dot save model and let's run this. So yeah, currently this is in processing. Yeah, it's done. Now you can able to see that in this folder your trainer model got saved. Your trainer model got saved. Now I want to save the model related configurations file in this model save folder. That is in this folder. I want to save that. And in the same folder, I want to save the pre-trained model as well. You can say I'm opening that folder here. Yeah, now I'm running this cell as well. You can see these three files got saved. You can reload it so that. So what is the model save folder? So let's open back and let's reload it and let's open this. Here the model related files are saved. Yeah, here also the configuration related files are saved. Okay. So now we saved the configuration and model related details. So in order to upload my files to S3, so let's store here the results, or you can say let's store here the artifact files. So before storing, we need these things, that is the SageMaker session details as well as the role, region as well as the image URI. You can observe here I'm using this framework DJL deep speed framework I'm using with this version. And region I am specifying whatever the where the SageMaker session is running. That region I'm using for this image URI. Now I'm just running this. You can see all these parameters right now will get taken, will get considered. You can see this image URI we're gonna use at the end. So while deploying our model, we use this. So just remember this. Now I want to save the artifacts. So in order to save the artifacts, you can see I'm just removing. Is there any folder with this name? Currently there is no folder with this name. And I'm making this directory. In that I'm making this folder. So there first in this I'm just copying the files, that is this present in this Dolly-V2-3B LoRa, that is here, and just I'm pasting that in this newly created folder. So similarly this bin file also I'm copying and that also I'm storing in the LoRa model. Now I'm just running this. I think we just encountered a small error, that is this no such active directory. So let's open. Yeah, we have this Dolly-V2-3B LoRa, right? So let's open this. In this, do we have this adapter config? No, we do not have that, right? Yeah, currently we do not have that.
Yes, no problem.
This might happen due to there will be a misconfiguration while saving. So let's see. I think yeah. So in this folder, this model save folder, do we saved? Yeah. So let's provide a name as well here, or else let's. Might here we saved some configuration files in this bucket, right? That is in this folder. So let's open this. and check. Yeah, here the adapter configuration JSON files are present. So now let's put these into the same folder, that is our model saved folder, into the same folder, or else you can just rerun this command so that there only these also saved. So let's rerun it. Yeah, it's done. You can open this Dolly-3B LoRa. Yeah, you can see here config files are also saved. Yeah, adapter config files are saved. Now we can create the artifacts right now. Yeah, yeah, this also get run, would not get any error. That is our artifact files also created. Now you just move back a bit folder. You can see this LoRa model created in this Dolly-3B. LoRa model was visible. If you open this, then there the configurations that you stored, that is JSON as well as bin file, those all visible there. Now in this LoRa model itself, let's save this configuration, that is serving properties, that is in what engine we are running, and what is the endpoint, that is our model Python file name, and so what is the folder and adapter name. Now I'm just running this. So then let's provide the properties as well, that is requirements in this LoRa model. So I'm just running this so that this file also saved in this LoRa model. In this LoRa model, I provided the requirements and serving properties as well. And let's save the other requirements. Now let's save the interface functions as well. That is under this utils dot, under this utils I have this deployment model.py, that also I'm saving as model.py in this LoRa model. Now I'm just running this cell as well, and I'll show you what code that I have in this deployment model.py. If you see, so this is the code that I have. This is just the instruction pipeline related code. So this is just a sample code. You can write such type of codes by using code whisper in real time, so that, or you can even able to create your own code to handle and to tackle and for the pipeline as well. Now let's move on with, yeah, so this we run. Then next, let's do uploading this LoRa model into S3. In order to upload this model into S3, now what I want to zip this file. So for that, I'm writing this command, that is a tar cvzf LoRa model tar.gz. So in that zip, I'm providing the content which is present in this model, which is present in this folder. You can see that content will be zipped, and if you observe, yeah, so that LoRa model tar gz got available here. So that is this. Now we need to upload this to S3 bucket, right? Yeah, so for that, let's write the code. Now here I'm writing the code. You can see I imported the required libraries. Then I created S3 connection, and then I created a client connection for S3. Now you can see I identified the bucket which starts with this artifact file name, and into that I'm uploading this LoRa model tar zip file with the same name. Now I'm just running this so that that file got uploaded there. You can see with this bucket name, actually our file got uploaded. Now we can use that file in order to deploy our model. So let's see how to deploy as well. Here itself, let's see how to deploy our model as well. Before deployment, we need to provide the model data. You can see that I provided the same zip file which is present in my S3 that we just uploaded. Then we are specifying the model related image ID, image URI. That is what we get previously while running this code. You can see this is the URI that we get, right? Yeah. Then if you observe the model data, that is nothing but the data, the model data that I am using, that we get from S3 bucket. This data is nothing but the same thing that we uploaded. And predictor class that I'm using this, and a role that I'm using AWS role. Now I'm just running this so that these configurations will be stored in it. So that's it. We just need to deploy this model. In order to deploy our model, we need to provide the runtime environment. That is, here you can say I am selected ML related G4DN 2x large runtime. Now I'm just running it. You can see our model will now just deploying. So one cell is running. Let's wait for a moment so that this gets deployed. Now you can see our kernel is in idle state. That means our model is just now deployed. So let's predict the output. You can see I've written this command, that is a predictor is equal predictor. This is the model that we provided. Dot predict of, we are providing the input, that is what solution comes pre-built with SageMaker Gemstart. Now I'm just running it to check the response. So currently the cell is running. So let's wait for a moment so that we get the response back to us. So it might take you, for the first time, it might take you for few seconds to minute. But the recursive time, that is, if you run it more than once, then you might get you a bit faster response as well. You can see we got the response. So what response we got? SageMaker Gemstart includes a solution that are pre-configured with all AWS services to launch a solution into production. Solutions are fully customizable. You can see we got the relevant answer, right? Yeah. Order your copy of SageMaker Gemstart today. Thank you for interest. Yeah. We got the relevant response only. Based on the trained model, we got the response. Now, in this way, you can able to use already available already available language model, and you can able to fine tune it, and you can able to deploy your model as well. So not only that, you can able to use it in your real time use case. You can see if you open SageMaker, there you can able to see the endpoints. There you can able to see the endpoints which are present under interfaces. You can see here endpoints. So after configuring, after deploying your model, here you can able to see the endpoints. Now I'm just copying this endpoint, and I'm gonna use it in my real-time application. That is, here you can see I've written some lambda code. It will just invoke our endpoint, and it will get the response from it based on the request that we provided. Now I'm opening this configurations, and here under environmental variables, I'm just providing that endpoint name and just saving it. Then you can see this lambda function is already attached to my API gateway. That is visible here. And if you observe it, for this, I've already created a CloudFront distribution. So let's open that CloudFront distribution and let's write some question, and let's get the response from there. So like that, in real time, you can able to get the response from your fine-tuned models. So for that, yeah, the cloud formation, this is the distribution. I'm just copying this domain name and pasting that here in one more new tab. Now I'm just copying the stage related address, and now I'm just pasting that in my website. Where is that?